Welcome to Dr. J's channel. In this video, I will be explaining energy transformations and efficiency. Firstly though, a big hello to the Year 8s at Ursula Frayne Catholic College. By the end of this video, you will be able to name the different types of energy and give an example for each. You will be able to state the principle of energy conservation. You will be able to draw an energy transformation equation. You will also understand the differences between input energy, output energy, and wasted energy. You will also be able to complete energy efficiency calculations. Firstly, what is energy? Energy is the ability to do work, or it could be loosely defined as the ability to make something happen. It is measured in joules, which is represented with a capital J. The two main types of energy are potential energy and kinetic energy. Potential energy relates to stored energy, while kinetic energy relates to movement. All energy types can be grouped as either potential and/or kinetic energy. So in this diagram here, what we've got is energy is our main idea. We have potential energy and kinetic energy, and some examples of potential energy might be chemical energy, which you might obtain from food or from batteries, gravitational potential energy, which relates to an object that is above the ground, and then we have elastic energy, so we store energy in the elastic when we stretch it out. Moving over to kinetic energy, examples of kinetic energy are sound energy, heat energy, and light energy. Electrical energy is a mixture between potential and kinetic energy. The law of conservation of energy is that energy can neither be created nor destroyed, but it can be transformed or changed from one type to another. So in this picture of the solar panel, the light energy comes from the sun. It's then transformed or converted into electrical energy using the solar panels. In this picture over here, chemical energy stored in the battery is transformed into electrical energy, which is then transformed into light energy through the light globe. So we can represent these using energy transformation equations, or also known as energy flow diagrams. In the previous example of the solar panel, we would have light energy as the input, electrical energy as the output, and the solar panel is the device that converted that energy. So in general, we have input energy on the left, output energy on the right, and the device that did the transforming sitting over the arrow. Okay, so some examples using our energy transformation equations. So if we had the light bulb and the battery, we could start off with chemical energy coming from the battery. It then becomes light energy through a light globe. If we had a television, we would have electrical energy at the input, we would have light and sound at the output, and the television is the object that's transforming the energy. Then we have a girl on a bike, so she has chemical energy, so that the girl eats food to gain that energy, so that's our chemical energy. It becomes kinetic energy, and that's through her being on the bike. Useful and wasted energy. In an energy transformation, in most cases, not all of the input energy can be transformed into useful output energy. Some of that energy gets wasted. Sometimes we say it gets lost. This wasted energy isn't destroyed. It's still there, but you can't transform it into useful energy. A lot of the time, this wasted energy becomes heat energy. So in general, we can say that the input energy becomes useful output energy plus wasted energy, and we have our device here that's doing that transformation. So continuing on from that, if we had an incandescent globe, and I've given you a picture of that because quite a lot of the time our globes nowadays are LEDs or some other type, but this is for an incandescent globe. We've got electrical energy going in. The incandescent globe is converting it to light energy and heat energy. So the amount of input energy that we have, say, is 100 joules. The amount of useful energy we get is 5 joules because that's our light energy, and then we have 95 joules being wasted. So the 100 has to equal the 5 plus 95. So notice that there's no energy that's disappeared or destroyed. It's still there, but we can't use it as useful output energy. Now, from this information, we can also calculate something called energy efficiency. So to measure how much input energy is transformed into useful output energy, the energy efficiency of a device is calculated. The way that we calculate it is that we divide the useful output energy by the total input energy and then times it by 100. So for that previous example, the total input energy was 100 joules. The useful output energy was 5 joules. So energy efficiency would be calculated as the useful output, the 5, divided by the total input, which is 100 times by 100% to give me 5%. It is better to have a device with a high efficiency, that is closer to 100%, than low efficiency. So you can see that an incandescent globe has a pretty low efficiency. So what you've learnt today, there are two main types of energy. These are kinetic energy and potential energy. Sound energy is an example of kinetic energy, while chemical energy is an example of potential energy. The principle of energy conservation is that energy is neither created nor destroyed, but can be transformed from one type to another. An energy transformation equation or an energy flow diagram is used to represent the transformation of energy. Input energy is written on the left, output energy on the right, and the device doing the transforming is written over the arrow. Energy efficiency measures how much of the input energy is converted to useful output energy and is calculated using energy efficiency is equal to useful output energy divided by the input energy times by 100%. Thank you for listening to my video. If you have any questions or suggestions, let me know in the comments. Thank you.